Welcome to Eeve, your Amazon co-purchasing network analysis. So, Eeve was initially inspired by how supply chain affects different supply markets and how knowing and having better knowledge of how the nodes are interconnected and which supplier provides what kind of products and are there any risks involved and what kind of suppliers are intermediaries delivering the product to the client. Knowing all of this, a comprehensive knowledge through the graph neural network can actually give us better insights, comprehensive insights in fact, and the Snap Amazon 0302 dataset is used over here for the graph analytics and community detection. The community detection is done using the Leuvian method. So this Leuvian method analyzes all of its neighbors, normalizes the necessary nodes, and provides the final outcome if any kind of supplier is at risk or is there any product that has to be shipped from one node to another within a limited period of time. Now let's look into the backend part, the IPYNB notebook, where ArangoDB is connected and it's powered by NVIDIA CuGraph as well. This is how the whole flow of the notebook goes. So first we install the necessary dependencies, the ArangoDB Network X graph, and also cuGraph as well, and Torch and the other dependencies necessary for us to formulate the graph, and Plotly for the analysis. So we prepare the dataset. So the Snap Amazon dataset 0302, which contains co-purchasing details, suppliers, and products. All of these are integrated as graph nodes and edges. So this dataset is retrieved from the provided public URL, and from that all of the edges and nodes are drafted. With that, we load the graph into Network X. Network X is more of a visualization tool which could comprehend different nodes and edges and also help us to identify the distance between the edges so that we could find the shortest path of supply, for example. And now to persist the graph, we load all of this data into ArangoDB, and for this we will be requiring credentials. And all of this in turn is converted into dictionaries as key value pairs, and then they are mapped. And finally, using Leuvian detection, the communities are analyzed. It acts homologous to a KNN classifier, and then all of this is visualized using Plotly package, and the agentic app is built using the OpenAI framework, which retrieves the data from the ArangoDB, and using LangChain via OpenAI API key, it helps us query the dataset. The first step involves setting up the environment. Here I've used a specific version of CuGraph, and these are all of the functions and packages which we will be using to visualize the nodes, and all of the LangChain packages and ArangoDB packages are for loading and persisting and querying the dataset. All of the packages are imported, and the ArangoDB credentials are given over here. All of this will be available on the ArangoDB dashboard and on the OpenAI dashboard as well. The dataset is loaded from this URL as a zip file, and now the graph is loaded into Network X. The data is taken and loaded, and this is a subset of the loaded graph. This is how it looks. Each product contains an ID. So over here in my code, I have created a pseudonym like product with ID product_1 is actually the product 1. Since the dataset contains a lot of products, more than 12 lakh of them, so this pseudonym is used for easy comprehension. and I've taken a subset of it which contains 300 plus nodes and 700 plus edges. And now we persist the graph data which is loaded into Network X into the Arango database. So what the Arango database does is it authorizes the user and loads the data, and with that we can query on all the nodes. And I've named it as supply chain VO. And this is the details of the data and how it is mapped. And now we use Luvian community detection to analyze the whole sample graph. It sets markers, and with this I've color coded them so that we know what supplier and what product is at risk. Here supplier X seems to be at risk while supplying to sanction US for product underscore 3. And here Nike seems to be at risk. Now to build the agentic app, we will be using LangChain and LangGraph powered by the OpenAI framework. And these are the tools which help us convert our text to an Arango query, and from the Arango query into the Network X algorithm through which we could query the nodes, get the distances, the shortest path of supply and everything, and finally that is again converted into a response text. So for the agentic application, I've called the tools, and this is how the output looks. These are the sample queries. It also specifies the risk cluster, and this can also be emulated into a Gradio interface. All of this is integrated into this web application that I've created. Now over here I can just give any query, or I can also take a sample query as well. And here which suppliers provide shoes, so Nike, Adidas, and another pseudonym supplier X as well. And now what suppliers are at risk due to potential disruption. So here using Luvian community and checking into the neighboring nodes, these like I've taken specifically for Nike, Adidas, and another supplier X. And this shows all of the risks and why, based on like what factors and geographical regions it is being spread. And now here for a specific product, these are the product communities and what kind of score they offer, so people can know like who to use as an intermediary to ship their products. All of this is connected, and this is the code for the entire application, and the Docker file is attached as well. And these are the web components. So with the power of GraphRag, and which is like ArangoDB and NVIDIA combined together, we can optimize all of the graph functions and also build neural networks over them, and create redirection algorithms as well. So this could save a lot of money for the economy, and also help in like effective analysis of how to go ahead when it comes to anything related to supply chain logistics. And this could also be compared to NP hard problems like the traveling salesman problems and edge detection problems as well, the Hamiltonian cycle, so that the best route and the best supplier for the best price for every product varies. So all of this can be analyzed in depth with Eeve. Thank you so much for your time, and a big shout out to ArangoDB and NVIDIA for organizing this.